Hey guys, my name is Nogan and welcome to my C++ series. Hope you guys are doing good. So in today's video, we are going to be focusing on extending dynamic memory allocation in C++, but today we'll be touching on classes and objects as a means of implementation with the dynamic memory allocation operators, for example, the new and delete keyword. If you haven't watched the previous video, we focus on how to use a new and delete keyword in C++. I'll link a card on top there because we just went through the applications of that, but now here we want to come to the abstraction of how we can try to use those memory allocation operators with class and objects now in a much more standard form of programming. Okay, so as you can see, we have like an empty project here in C++. So what I'll do right now is just define a few, like a class eventually contains our new and delete keyword as a means of now implementation. So also the main function here, I'm going to declare class, student, class student, yeah, awesome. Okay, so you have a class student now here. Now in here I'm going to declare a private member. We'll type int, but it'll be a pointer. Say data. We'll declare another public specifier, but this now it will declare like a few constructors. So it'll be like we'll have like a student constructor takes like a integer parameter. Okay, now here in this constructor eventually here we'll be focusing on trying to eventually now initialize the data when we declare now as a private member on top here. So in here, so data again, but now data, because now it's going to be initialized and using new keyword int and initialize it to the keyword of value. Awesome. So what is happening in this line of code 12 is that eventually we're using a new keyword to eventually allocate memory on the heap dynamically, eventually using now this variable being defined of int point data, initializing it now with this new int value parameter eventually here. Now after this, let's declare also a destructor, destructor student. Now in a destructor, because we are eventually declaring here the memory allocation, so which means based on by definition, it's now memory allocation in the heap. So this memory needs to be deallocated. So memory deallocated. Awesome. Now we may also try to use again here, very important, the delete keyword, because the delete keyword justified by saying the member needs to be freed after being used eventually in the based on compile or runtime execution. So basically, what's happening now? The constructor just construct now by initializing this data variable of int type, integer type, being defined in this private member specified here. So what's happened is we allocate the memory here, but not in a heap eventually, as you can see here. After this, we have to like free the memory so it can be used by other programs or programs. So which means now the delete keyword just justified by saying we have to now remove the memory from storage so it can be used by other programs and stuff. In the main function here, but before we get to the main function, let's try and use like declare another function. Let's just declare another a public specifier again. But now let's just declare like a variable, like a function, like a method. It's going to be int type. Let's say get value. So the const function. Now what you do is return now eventually that variable, that member. So then we return keyword pointer data. Let's make it much more nice. Yeah. Awesome. Okay, so eventually enable right now. We have now a variable here, or a function eventually, or method being defined on a public specifier of type int get value. Now this eventually just returns eventually now the data being stored in this pointer of type data. And the main function here, I'll just say again student. Let's say obj pointer. It's new student again. Initialize the data. Let's just say maybe 42. Awesome. Now I need to access eventually also now here. Access the member functions. Of the object. Okay. So when I say it says cout, see the value now stored in the data obj. I'm going to use now the arrow operator to eventually get the value. Awesome. If you don't know what is an arrow operator, guys, I'll leave the card on top there about, because there's a video about like what is an arrow operator in C++ and how it's being used eventually. So I'll just link the card on top to check it out if you're a little bit confused what is this symbol being used eventually here. Awesome. After this, I'm going to say the allocate again. Allocate memory for the object. Awesome. Now, when you allocate the memory again by very by definition, because remember, whenever there's a new keyword being implemented or used, there must be a delete keyword to justify that the memory being allocated now for a specific variable or member in a function or a class needs to be again now be free. So after this, it also now again use the delete keyword again. You just now remove the object data being stored, because remember, in the main functions you can see here on line 23, we eventually are declaring this is now an object pointer. Eventually, this is going to be eventually now we use the new keyword to try to allocate memory on the heap again for this constructor, basically linked to this constructor in the main class code here of public value. So it's interesting because now whenever there's a new keyword being implemented used, there must be a delete keyword to justify by saying, because it's not opening, it's closing, almost like a door. So they must go hand in hand as like a means of trying to make sure that now when memory is being allocated now on the heap, this should be free because of to avoid memory leakages in your program. So after this, let's just click Control Shift B to compile a program. Awesome. No errors. Let's run this. Awesome. Values 42. Awesome. And even if you, let's say for example, put a breakpoint here to check what's happening, and we run a program again. Okay, basically as you can see now on this window display here, the obj or now the object pointer now contains eventually like a memory address. That is, as you can see here, about student, the type, and also now this is the address eventually here. If you go on top here, next to stack frame on top here, you click on this button, says now step into. You can see where it's going. It's jumping from now the main function to eventually jumping to the class called student. We come to this line of code here by justify by saying we're going to be trying to eventually now allocate memory using the constructor for this pointer variable here of data. If you click on step in again, it jumps to now into the body of the constructor by saying, okay, the data now going to be stored in this variable here, but now on the heap eventually, as you can see also here. So this justify by saying eventually that the value is going to be stored eventually here will be basically based on the sequence of operations from the student constructor of type int, as you can see here, but the value that is stored there will be 42. It is 42. Why? Because now this in the main function we eventually declared or specified a value for the 2 here. If you step into again, this goes out and jumps to the main function again. If you step into again, eventually it jumps to the line of code of 35, and as you can see here, it just shows the output eventually now, as you can see also here, of that value being stored in there. If you step into again, it just comes to the function again on top here of int that value to just justify by saying now the function is also getting called based on execution in the program, so where the data is going to be returned eventually as a means of output, as you can see here. And if you step into again, you can go to that line of code, and afterwards jump again back here to justify by saying now this function is being called is based on the error operator as a means of execution to getting that value now being stored in there. And instead of enter again, it goes to the last line of code for operations to delete obj file, obj object variable. So it justifies by saying now a breakpoint analysis, guys, is very important because it shows you like where in the line of code your program is executed and how everything flows in the sequence of operations and stuff. And it's also like a time sequence here, time elapse here. It's very important for more like observation and also more analysis. Awesome. Guys, I hope you enjoyed the video. If you have any questions, don't forget to comment down below. But this type of programming is very important for making sure that now at least when it comes to programming, you have to utilize data structures much more often, because there will be a sequence where now we're going to also try to implement this type of programming with data structures in C++ and how they can be used to optimize your program so it can become much more efficient and stuff. Thank you for watching once again. Don't forget to like, subscribe if you're new, and see you next time.